If you ever work with prefabs in Unity, there are two methods you won't be able to live without. First, instantiate, a method to create a copy of a game object, including every component and subsequent game object in the hierarchy. Second, destroy. This deletes the given game object, as well as everything in the hierarchy below it, and with that, frees all the previously allocated memory for garbage collection. Now, if we use this every once in a while, there's actually not much harm. But if we use the same logic in rapid succession, like for example with bullets in a tower defense game, this will put a growing strain on our performance because we need computing power to first create a new copy for every single bullet, and then again once it's destroyed and the garbage collection kicks in. With that out of the way, hello and welcome to I Create My Games. I'm Jens, and today we're talking about a solution to that problem. This is Object Pooling Part 1, Pooling Basics. The general idea is that we create a pool of objects at startup to be reused whenever necessary. So for a tower defense game, this could mean that we create 20 inactive projectiles. Then, when an enemy comes into range, we grab a projectile from our pool, set the position, rotation, and then activate it. Once the target is reached, we can requeue it to be used for the next enemy. Well, I couldn't actually prepare for tower defense for this tutorial, so let's instead work with a simple example. I have a blue line indicating the floor, I have a player as a red dot, and I'm creating every second right now the collectibles at the top of the screen. Once I collect them with my player, I'm instantiating a particle system, a smiley face. If I'm not fast enough and they hit the floor, I will create a particle system indicating an explosion. So let's test it out real quick. I move around and I'm collecting it with the smiley, and if I don't, the explosion is created. Now, if you are looking to recreate the exact same thing, you will need two asset packs, both free. The first one is Cartoon FX3, which holds the particle effects and is on the Unity Asset Store. The second one is the background, Parallax Forest background on itch.io by Digital Moons. I will link them, of course, in the description. Now for the implementation, let's go not too much into detail because for everyone this might look a little bit different. The important part is that I'm using currently the instantiate and the destroy method. So for the collectible spawner, I assign a prefab collectible and a time whenever I want to spawn it. So currently it's at 1 second distance. So inside I have a coroutine which will be called every second, or which will run the code every second. And I'm using the instantiate method to create a copy and assign a random position on the x-axis. Then for the collectible itself, I have two objects assigned, one for the particle system for when I hit the floor and one for the particle system for when I hit the player. Then I have a little bit of initialization, so it's a random speed, a random color, and a random scale. And for the trigger enter method, I verify it if it's the floor, use the destroy method to destroy my current game object, and instantiate the particle system for the floor, and do the same for the player, so I destroy the game object and instantiate the particle system for the player. Now, since these methods are working but aren't really optimized for performance, let's start with the implementation of the pool. And to do that, let's start with the very basic implementation, and over the next few episodes work our way up to a more complex, more versatile implementation. So we start with a new C# script, which will be the object pool. And we're not using them, these as a component. It's a simple basic C# class, but we don't need a constructor. So we can simply call a own init method, init pool method, where we want to initialize everything. Now, to initialize everything, we of course need to know what we want to initialize. So we need a variable. Let's go with public game object prefab to pool. So we know what we want to pool. Then we need another variable, public integer amount to pool. So we know how many we want to prepare, and we need a structure to hold the information. Now we could easily use a list, but for a simple implementation, a queue is the best option because it works with the first in, first out option, which means that the thing we are currently getting from our queue will be the thing most likely to be reusable since it's the longest in the queue. So private queue of game objects, which will hold the pool queue, which will hold all the pooled items. Now in the initialization, we need the pool queue to be a new queue. So we created new. And for our objects, we loop from 0 to the amount and enqueue these new items or newly created or prepared items. But to do that, and since they need a little bit of setup, and this will be complexer over time, I will create a method, public game object prepare copy, where we create a game object copy. Usually we would use the instantiate method, but we can't access it without a game object. So we can use the static reference to it, game object.instantiate. And here we only need our prefab as a copy. Now for the copy itself, we need to make sure that it's not active. And then we simply return the copy. Again, very basic implementation. This will extend over time. But right now we can simply call the method here. And we have everything in our queue. Now to access these informations, we need another method, which we will create. So it's public game object. Let's make this private so we can only access it inside our class. Public game object spawn at, which will be the function we want to call instead of the usual instantiation function inside our wherever we want to spawn an obstacle. So it will be instead of this. So we need a way to give it a position and a rotation. So let's go with vector3 position and vector3 Euler rotation. Now I'm using the Euler rotation, which is basically the rotation around the axis, the one we can see in usually the transform if I'm not currently having so many errors. So this is the Euler rotation, but Unity uses quaternions, which is the ones we usually need to apply. But for me personally, I like to work with these Euler rotations, and since I don't need to use any multiplications or calculations with these, I can simply use the vectors. So I will get the current or the one currently object I want. So it's game object go get next in line, a method I will create soon. Then I need to apply the position and I need to apply the rotation. And to do that, we can simply parse it. So it's Euler rotation like this. Or we could also go with Euler angles and set them directly. Now I also need to make sure that my game object is active. So it's set active true. And I can simply return the game object. So this method will be called from outside. So we can also always get the one currently best suited for us. Now the getInLine method is only for us inside. So we use a private game object get next in line, which will give us the current object next in line. Now, first of all, we need to verify that our queue, so it's poolqueue.count, has items. Bigger, there. And the one currently at the top of the queue is usable. So we can use the peek method, which will look at the first but not dequeue it. And since it's a game object, we can look active self. If it's active, we can't reuse it since it's still used somewhere. So we go with and not active. We return our pooled queue dot dequeue game object. Or we can do something like this, game object, go. Then say our game object is the one at the top position, since we have something at the top position and we can use it. But if we don't, we can simply create another copy. So prepare copy. If we ever realize that our current object is isn't usable since not enough is there, we can simply create one again. And then we can return our game object. But first we need to make sure that we put it back in our queue, no matter if it's the currently, if it's from the queue or we created a new. So next time we're there, we can reuse it. So it's poolqueue.enqueue, the game object. So the next inline function verifies that we can use the one currently at the top of the queue. If we can, we simply use that one. Otherwise, we create a new copy. And that's it for the object pool. Now, to use that on a game object, we need another class, which will be the object pool handler, where we want to use the mono behavior so we can use it as a component. Now inside this method, I want to use a singleton pattern, which means I only want to have one instance of this and I can access it without a reference to the specific object. So to do that, we need a private variable of our current object pool handler. Let's call it current. And we need to make sure that this is static so we can access it with the class instead of an object. So static means it's only once in this class and we can access it from everywhere. Then we need, of course, a way to store our information. So it's the pools list for object pool. And then we go with prefabs to pool. Now in our awake method, we need to make sure that the current variable is set to this instance of the object. So we always have a reference to it. And now we only need to make sure that we initialize our pools. So it's for each in our prefabs to pool collection, we can go with init pool. And to access it, we create a static method so we can access it without the without an object. Public static game object spawn at. And here we need, of course, a reference to what we want to spawn. So this will be game object, the prefab we usually would use to instantiate. We also need the position. And we need the rotation. And again, I used the Euler rotation. Now for the spawning, we simply make sure that we return anything if nothing exists. So something went wrong, and otherwise we loop again our list, prefabs to pool, current dot prefabs to pool. We need the current modifier so we have a static reference. And here we can simply go with item, if item dot prefab to pool. So the one we want to pool is the same we are currently asking for. We can return item dot spawn at position and Euler rotation, which will uses the spawnhead method we previously created, which will give us the next in line with the current position and rotation. So with this, we have everything set up for the basic controller. Now we need an object where we can apply it to. Let's call it object pool handler as well. Put our object pool handler inside. Make sure that our object pool is serializable, because otherwise we can't access it. We do this with system.serializable. And now we have a list with serialized objects. So we can create one, for example, where I do this for the collectible. And we will start with the amount 0, so we can extend the amount over. Now let's start with 20 and verify that we can extend it at a later point. So in the spawner, we now need to make sure that we don't use the instantiate method, but rather the object pool handler variation. So let's go with object pool handler, and I'm using static so I can access it like this. Use the spawnhead method. Use the prefab previously used, collectible to spawn, and the position I want to use. And here I can, since I don't need any rotation, I can simply go with the vector free 0. Now if we switch back to Unity, we can see already the first things working. So play and pause. And in the awake function of our pool handler, all our collectibles are created, 20 to be exact. And the start function of the spawner is called, so the first collectible is already requested and positioned at a reasonable position. Now, this still will be a problem, or the current implementation will be a problem, because our logic dictates once we hit with a collectible the floor or the player, we simply destroy it. And therefore the collectible won't be accessible in our queue anymore. So we need to make sure that we don't destroy it and change it to not active. So let's go to the collectible, comment the destruction method out, and go with gameObject.setActive to false. And do the same for the player. And with that, our basic queue is ready. Now the instantiation of the floor particle and the player particle we will change in the next, but let's check out how everything works. So let's hit play. Our collectible is created, the first one is requested, and I can start to move them through. And our queue will always use the next in line, so we can see how this moves forward through the line. And once we hit the very last one, since our objects are already requeued, we will simply restart with the very first. And so we don't have a problem. And that's it for this episode. As I mentioned before, this is only the very basic implementation for the object pool. Over the next 2 episodes, we will increase the functionality, for example, a different data structure to hold our pooled objects, or we could use an interface to increase the flexibility. If you have any questions so far, feel free to comment. I'll do my best to answer as fast as possible. Oh, by the way, the background was created with the Parallax controller from my Parallax tutorials. If you liked the video, consider subscribing. It really helps me and my channel out. Thank you guys so much for watching, and I'll see you next time.